Hey everybody, it's Miss Hill, and we're back for the first official lesson of quarter four. And today we're going to be talking about slope. Slopes are all around you, they are everywhere, and I am sure that you have heard about the term slope before. Slope is just a constant rate of change. So go ahead and title the top of the next clean page in your spiral with the title Slope, a rate of change. And more specifically, if I'm going to do a little definition vocab work here, it is a constant, means not changing, rate of change. And specifically, it is the change in y, which is on a graph, the vertical, over, and over always means a fraction, right? So over the change in x, which is the horizontal or side to side, you could think about. When I think about slope, like I said, it is going to be a constant change. So when I'm looking at a graph, I have four different types of slope that I might actually see when I'm looking at a specific graph. So I'm going to do some sketches here, nothing wild and fancy, but let me give you those four examples of slope. And I'm just going to draw four quick little coordinate grids. I'm not working on graph paper, so I'm just eyeballing it. Let's say that I had a line, right? A slope is always going to be a rate of change that is on a line on a graph. So let's say that I had a line on this graph, and this line went something like this. So it started, if I'm moving left to right, it is actually increasing, right? It's going up as I move left to right. This type of slope would be called a positive slope. It's increasing or going up as I move left to right. So then the opposite would be also true. Let's say that I have a line like that. So as I move on this graph left to right, that slope or that line is headed in a negative direction. It's actually headed down. So that type of slope, if I'm just categorizing them, would be called negative. Now notice I'm not finding the slope here. I'm just identifying, does this thing increase in a positive way? Is it decreasing in a negative way? Or even more specifically, you might have something that ends up looking like this. So you might have a perfectly horizontal line. Horizontal meaning just completely straight across. There's no rise. It's not increasing, right? And it's in its y value in any way. So this is called a zero slope, meaning there is no change. And then the last type of slope is a little bit more challenging to understand, but it would be the type of slope, or the type of line, I should say, that might look something like this. So that perfectly vertical line, that line going absolutely straight up and down. In math, we call this undefined. Right? To define something would be to know what its value is or be able to label it. And this is something we can't identify. It is undefined because from one point to another, there's no run, meaning there is no change in the x. So I'm going to put that here underneath 0. There's no y change. And in undefined, there's no x change. What I mean by that is, right, that line is not moving in any direction on either the y-axis for 0 or the x-axis for undefined. So you're going to hear that language, and it's really important to be able to identify what type of slope you have so that you can then check your answers when you're trying to actually identify slope. So let's look at some graphs, and what we're going to do is we're going to talk about how to actually find the slope of a line. So what is the rate of change in that line? What's happening over and over and over again to that line as we move from left to right? So let's set up example number 1. And what I will do is I'll show you an example of finding a positive slope, an example of finding a negative, and then 0 and undefined as well. So we'll look at very specifics. So let's look at this graph. And again, I'm just sketching. I'm not getting real fancy because we're simply looking at the meaning behind slope. Now let's say that I have this line, and I'm going to draw it straight through what we call the origin, or that point at 0, 0. And then I'm going to label 2 different points on this graph. And I'm going to say to you this point is at 2, 2, which means that it moved over 1, 2 spots. Same thing here, 1, 2. And I'm also going to say that it moved down 1, 2 spots, or 1, 2. So what that would mean is that this point is at negative 2, negative 2. So I want to look at this graph, and all I want to do is find the slope by drawing what we call a slope triangle and counting how far did we rise and how far did we run. Now you're like, wait, what's she talking about? Rising and running? So slope up above, we said that slope is the constant rate of change in y over the change in x. So y represents the vertical, the up and down. That's the rise. So how far up is it going? Over the change in x, meaning how far over is it running or moving to the right. So rise would be how far up did it go, and run would be how far over did it go. So if I'm trying to find the slope here, actually put like a box around this because this will be your best friend right here as we move forward. So if I'm trying to find the slope of this particular line, I want to think about rise over run. So I'm going to write this. Slope equals rise over run. So I'm going to start at my first point. And what I'm going to do is I'm going to count how far up and then how far over do I need to go so I can get from point A to point B. Now here's what I mean. So I'm starting at point A. I need to go up 1, 2, 3, 4. So I had to go up 1, 2, 3, 4. Again, we're just doing the best we can here. So I had to rise 4. And then I had to run or go to the right 1, 2, 3, 4. Yes, so didn't hit that point very well. You get the idea. I had to go over 1, 2, 3, 4 to get to that second point, right? So I'm trying to go from one point to the next. Again, I went over 4. And then I just want to write that fraction as simply as I possibly can. 4 divided by 4 is just going to give me 1. So in this case, even though it's very poorly drawn, the slope is 1. Meaning for every move up I take, I move over 1 as well. Okay, let's take a look at a second example. And this time we'll look at kind of the same idea, but let's look at negative. So example number 2. I'll do a little better job drawing here. Sketch this guy. Okay, so draw my line. And this time, let's talk about this point as point A and this point as point B. And this time I had to, so this point, let's call this guy, that is at -1 and +2, meaning it went over 1 and then up 2. And let's say that this point is at +2, so over 2 and down 2, -2. So I want to move from point A to point B. I know it seems silly to keep writing rise over run, but it really will help you remember. So if I'm going from point A to point B, first of all, look at this picture. Which one of these types of slope does that look like? It looks like this negative slope right here. So let's see if my number actually comes out negative. So to move from point A to point B, I'm doing rise over run. But if I rise up, what happens? I'm off my graph, right? So instead of rising, I actually have to fall. I've got to go down here. So I'm going to go down 1, 2, 3, 4. I went down 1, 2, 3, 4. So instead of it being a rise going up 4, I went down 4. So I need to put that negative to show the direction I went. And then to get from here to B, I'm going 1, 2, 3. That was a +3 because I went to the right. It would have been negative if I had to go left. Okay, there's nothing I can do to simplify that. We don't want to make that a mixed number when you're talking about slope. You always want to leave it as a single number over another single number, even though this is an improper fraction. What we're going to say is this slope is a -4/3. And it did come out as a negative number, right? Showing that that direction, it is headed down as we go from left to right. Okay, let's quickly, as I know this video is getting a bit long, let's quickly take a look at what an actual 0 and undefined would look like. So let's look at example number 3. Again, simple sketch. And I'm going to draw a line right here, perfectly horizontal, meaning side to side. And I'm going to give us this information. So if I pick any point on this line, any 2 points, let's say this is point A and point B, what are those points? Well, up 2 and over 2 to the left. So this point is at 2, -2. And this point is up 2 and over 2. So 2, 2. So when I'm finding my slope, again, I'm going to write this out because I want to memorize this. Rise over run. So to get from point A to point B, I don't rise or fall, right? I don't go up or down. So the rise is 0. I do have run. I have a run though here. I've got 1, 2, 3, 4. So I went over 4. But I have 0/4. So if I simplify that, I simply get the slope of 0. So any horizontal line like that, 0 slope. And that last example is of our vertical line. Quick sketch. This guy. And we'll give some points. So if I'm at this point, that could be point A, and that is at 2, 1. And this could be point B, and that is at 2, negative 1. So again, if I'm looking at slope, slope is rise over run. So if I'm at point A and I want to get to point B, I'm actually going to move down 1, 2. So I had a negative 2. However, the run or the moving to the right, it never went right or left. So that was 0. And here's why we call this thing undefined. We would give it a final answer as undefined. And the reason for that is because of this 0 in the denominator. We cannot have negative 2 zeros. You cannot have that many zeros, right? We cannot have a denominator of 0. So in this case, what we do to define it the best way we can is say that it can't be defined. We call that type undefined. I hope that this information helped. The goal this week is simply just to begin to understand that slope is a rate of change, that I can have positive, negative, 0, and undefined slopes, and begin to practice actually finding slopes from a graph. Right? Have a great rest of your week.